Saxon Advanced Mathematics, Lesson 82. Students, greetings. Welcome to another glorious day of mathematics. I'm excited to teach you this lesson. I think it's going to make you feel smart. And it connects back to some things we've studied in the past. So I hope you enjoy it half as much as I do, because then you'll be happy. Okay, let me take us back to something that we've talked about before that mirrors this. If I have an expression like this, that looks very tame, right? And we know what to do. We, listen to the words, we take the square root of both sides, right? We're allowed to do that. We see this square of this and we know, boy, the only way to get this by itself is to take the square root, and then we can go on and quite simply solve from there, can't we? All right, this is the model for what we're going to do today, which is a little bit different. Let me show you the first example. Let's dive in and I'll explain as we go. We are asked to solve this expression. This is an exponential equation, ba-boom, boom. And we have two bases. We have an exponent. What really triggers our brains in this is that we have variables in the exponent. That's what tells us we might want to take a log of both sides, because let's just see what it looks like. I'm going to just write, just like we can introduce this symbol anytime we want, I can write log 10 minus 2x plus 2 equals log of 8. Just like we have to take the square root of both sides, we have to take the log of both sides. Now, I chose to take the common log. That has a base of 10, right, implied in it. I don't have to write that 10 in there any more than I have to write the 2 up here, right? I could have used the natural log, right, that has a base of e, but I saw this 10 and I thought, ooh, that could make things easier if I use the base of 10, right? That just seemed, when I saw this, that gave me the hint. So when to take the log of something, we have to choose log or e. We can use the natural log, and we'll do that in a minute. But in this one, as soon as we see that 10, we think, oh, let's take the log of both sides, or the common log rather than the natural log. The 10, right? Clicked with us. Well, let's use the base 10. Okay, now what's magical is that we know that the power rule of the laws of logarithms allow me to take this and jump it down here in front. So we use the power rule on the exponent. Okay, so I'm going to take that and bring it down, minus 2x plus 2, and it is always safe to put parentheses around that. Using the power rule, just like any of our rules for exponents, you don't have to do the same thing to both sides. We're just simplifying on one side. Okay, now, this looks good. Let's think for a second. What is the exponent? Let's simplify this part of it. I'm looking at this right here. And I'm thinking, okay, we've got a base of 10. We want the number to be 10. What is the exponent that we put on 10 to get 10? Oh, it's 1. So this is an identity that we can logic out quickly enough, but you should see that whenever you're asked to find a number that's equal to your base, it's going to be 1. So this cancels. And now we have minus 2x plus 2. I feel comfortable with the parentheses off now. Equals, now this I'm going to go to my calculator and find a value for this. Using my, do you remember when you were a little kid and you used to well, I think you probably did this. My kids did it all the time. They would make play money, for their games. This, I always feel like I'm using play money. This is my play calculator. And I would give them old calculators and they would feel very smart and important. We're using this row of buttons, right? We know that our number is 8 and we want to use the base of 10. So this is the button. So I enter 8, I hit this button, and the value that I get is 0.9031. Okay, so this is the log 10 calculator button. This is my symbol, by the way, in case you hadn't caught it. This is my icon for using a calculator button, that sort of rounded off rectangle. It looks like the buttons on my calculator. Okay, so now we have eliminated this log, reduced this one to a number, and now all we have to do is solve it. I'm going to subtract 2 from both sides. I get minus 2x equals, let's see, that would be minus 1.0969. And then we divide both sides by minus 2. And we get x equals 0.5485. You can do this work on a calculator. I do want you to carry it out to 4 decimal places. I want to write some other steps on this. I'll go to the next page. Okay, so we used the power rule, then we simplify the logs and solve. That would be my last instruction to you. Let me flip over. Three, simplify the logs and solve. Beautiful. Okay, so that's the first example. Did I get it smiley faced properly? No, I did not. Oh my gosh. Better. Okay, let's do the second example. There are 4 in all, by the way. This will not be an hour-long lesson like the one I gave you recently. That was such an ordeal. 82.2, solve. E Okay, so what triggers us is that we have an exponential equation and we have variables in the exponents. That's what really triggers us. And I think I told you that. Variables and exponent, yeah, see here? That's our hint that we want to take the log of these exponential equations. Okay, so exponential, variables in the exponent. This time, it would make sense to take the natural log of both sides, wouldn't it? Because of that e. So that's our hint, okay? Now, taking the natural log always feels weird because you say you're gonna take the log, but we're writing something that doesn't look like a log at all. The natural log of this thing equals the natural log of 5. Then we're gonna pop this down using the product rule, so we'll get minus 2x plus 3. I'll put that in parentheses. Natural log of e equals the natural log of 5. Okay, just like last time, this draws our curiosity. What is the exponent that we put on the base of e, right? Because this is a base of e. To get e, oh, we can memorize this. The natural log of e always equals 1. Okay, so then this becomes minus 2x plus 3 equals the natural log. Again, we can use a calculator. We'll want to use this button. So we'll enter 5, and then we'll use this guy, and we'll find that the value for, oh, yeah, natural log of 5. Okay. It is 1.6094. Beautiful, right? Now it's just algebra. Subtract the 3. And then divide both sides by minus 2. You can do these calculations on your calculator. Once you start using the calculator for a certain kind of problem, you might as well finish carrying your answer in there. And our final value is x equals 0.6953. Again, 4 decimal places for these. Is that right? Yes. Dun, da, da, da. Beautiful, right? Okay, so in the first problem, we had a 10 as one of the bases in the problem, so that made us choose the common log. In this one, we saw a base of e, so we chose the natural log. Now let's consider what happens if your bases are more random. All right, how do we know what to do? Oh yeah, we've got bases and exponents. So this is an exponential equation, and we've got variables in our exponents. So in order to solve these, we want to be able to jump them down, and we can accomplish that by quote unquote taking the log of both sides. That's the thinking process. That's how you know what to do. So our next question is, which log do we want to use? This is a 5 and this is a 6. That doesn't really scream either methods. And here's the real fun of this. It doesn't matter. You can do it either way. In fact, the other two problems that we chose to do the 10 and the e, you could have used the opposite logs on them. The different bases, right? We could have mixed it up and done it the other way. It makes a little more work. So I don't know about you, but I'm never looking for more work in my math problems. But in this case, we just have to choose one or the other, and I'm going to choose the common log. So what I'm going to do is I'm going to take the log of both sides. And then that allows me to jump these exponents down. I'll put them in parentheses. Now I will use my calculator, this button, and I know that this is the number I want, so I'm looking for the exponent that I need to put on that 10 in order to show that as the log. I mean, that's what the number is that's the exponent that goes up there. Okay, so the front quantity stays the same. I use my calculator, 5 log 10 button, and I get 0.6990. I worked these out ahead of time since I knew I wouldn't have my calculator at my fingertips. 0.7782. 4 decimal places. Now we have to distribute. Ay, 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 right? So we're distributing these big hairy decimal numbers across the things that used to be our exponents. So what do we get? 1.398x. It's kind of crazy, right? 6. Oh, I ran out of space. 4. Okay? Distribution. The only thing that's hard about that is that it's a 4-digit decimal. Ew. All right. And now, again, I'm just algebraing. I think I'll subtract 0.7782x. And I'll add the 0.6690. And I get that cancels, equals, and then here I'm going to have minus 0.8574. And here's my x, so I want to divide by this. And that gives us an x equals that's our final answer, and let me just triple check and make sure that's right. Yes. One of the frustrations for me in these problems is that there's nothing logical about this answer, right? We can't look at this and go, oh yes, of course that's what it is. We just have to kind of trust our calculations. There's no real common sense way to test this answer easily, which is a little bit frustrating for me. I prefer an answer where you can look at it and go, oh, that makes sense, cool. But this is the right answer, so yay. Okay, we have one more. And this introduces a new little trick. Okay, well, it's an exponential equation with a variable in the exponent, so we know taking the log is the way we want to go. We see the e, so that makes me think, oh, well, taking the natural log probably makes a little more sense. So we will take the natural log of both sides. And I still haven't figured out what we're going to do about this. We still haven't dealt with this, I guess is what I should say. I have a plan. Don't worry. This is a problem, right? This is different than what we've had in the past, where we're multiplying down here in the base. But let's go ahead and deal with this now. What we can do, let's see, this is all one big chunk. What we can do is split apart the 6 and the e. So I'm going to rewrite that. It's going to be the natural log of 6 plus the natural log of e. When we're multiplying, we can change it into addition, right? When we've got multiplication in the argument, the product rule / law of logarithms tells us we can split that apart, right? Usually we take it in the other direction. Usually we simplify this by multiplying these two together, but now we're using that law in the opposite direction, and we're using it to split them apart. Calculator, calculator. Oh, wait, let me not get ahead of myself. Now we jump this down. This we go to the calculator and we get a value of 1.3863 equals natural log of 6, that's 1.7918, plus, okay, here we have one of those identity things where we know that the natural log of e always equals 1. Because we're asking, what is the exponent that you put on the base of e to get the number e? 1. So this drops off and we just get plus 2x plus 3. Fabulous. So now what I'm going to do is I'm going to move all the plain numbers over here to the left. Now we're just doing some algebra. I'm going to subtract the 1.7913 and I'm going to subtract the 3. I won't. And so this will be minus 4, right, if I put those two together. 4.7913. I didn't take the time to, I could have rewritten this and added those like terms and then subtracted them, but I just took a little shortcut and subtracted them before I added them together, and I added them there. Minus 4.55 equals just 2x left on that side. There's my x. Divided by 2, I get x equals minus 1.7028. That's the right answer. So what I want you to remember, what we did right here, we remember that. We used this law of logarithms. Here, this is two things multiplied together, so we're allowed to split it apart. And we chose to let the exponent stay on the e. I guess that's where it's supposed to be. It has to be on the e. We couldn't have moved it over to the 6. So the e and this were the bundle, and then the 6 we split apart, just like we can do here. All right? So, and we knew that was what we needed to do because we had two things being multiplied together here. All right? All right, that's the end of lesson 82. I hope you're to the point. Logs freak us out when we are first studying them. They're weird, they are different. They involve freaky buttons on the calculator. They have a lot of intimidating features. But I hope that at this point you're seeing that they're just kind of a fun little calculation. We do mental gymnastics with them, and it's fine. They're just another little piece of the puzzle, right? Okay. Next lesson is about probability. So that always feels like a vacation, doesn't it, on our brains? No trig identities coming up next. Okay, thank you. Goodbye.